In this video, I will show you how to simplify radical expressions by rationalizing the denominator. So in most cases, you should start by simplifying the denominator. So in this case, the denominator is simply the square root of 16. And we know that the square root of 16 is just going to be 4. So this is going to immediately give us 5 radical 9 over 4. But you know what, at the same time, 9 is also a perfect square. So we might as well do that as well. So the square root of 9 is 3. So that brings us to this. But this is 5 times 3, so that's going to be 15. So we have 15 over 4. And that's as far as we can go with problem number 1. So that one was a little bit unusual since both radicals were perfect squares and could be simplified by themselves. Usually that won't happen. So look at number 3. Let's start with radical 8. Focus on the denominator. So I have radical 8, the square root of 8. Now 8, if I sort of break this down using a factor tree, okay, 8 is 2 times 4. All right, 2 is a prime number, so that's the end of that branch. And then 4 is 2 times 2. So, in other words, the prime factorization of 8 is 2 times 2 times 2. So when we talk about the square root of 8, we can think of that as the square root of 2 times 2 times 2. Now, every pair of numbers is going to come outside of the radical as just a regular number. So this pair of 2's is going to give us a single 2 outside the radical. Alright, now this single 2 will be left inside the radical. Alright, so the square root of 8 is the same thing as 2 radical 2. So let's do that so far. So now I have 5 radical 2 over 2 radical 2. Well, this is a nice little coincidence. I have radical 2 in the numerator and the denominator, so those will cancel out. So the final answer will simply be 5 over 2. Okay, that was a little bit of a coincidence. So let's keep going. All right, looking at problem number 5. Focus on that denominator once again. So I need to work with the square root of 80. I need to simplify that down as far as I can. Let's do the factor tree for that. So 80, of course, is 8 times 10. But then 8 is 2 times 4. All right, 2 is a prime number. 4 is 2 times 2. All right, that's the end of that. 10 is 2 times 5. Both of those are primes. So that means the square root of 80, look, I have 4 2's. So the square root of 80 is the same thing as 2 times 2 times 2 times 2 times 5. Okay? Now, every pair of numbers is going to become a single number outside of the radical. All right, so this pair of 2's is going to become a single 2 outside of the radical. This pair of 2's is going to also become a single 2 outside of the radical. This single 5 has to stay in the radical. And this is now multiplication, so this is going to give us 4 radical 5. So putting that back into the problem, now I have 3 radical 15 over, let's see, we got the 2, and then radical 80 becomes 4 radical 5. So 2 times 4 radical 5. So let's go ahead and simplify that a little bit further. So now I've got 3 radical 15 over 8, right? 2 times 4, 8 radical 5. Now, normally I would have to multiply by radical 5 in the numerator and the denominator in order to get rid of this radical. But there's something much simpler that I can do instead because of the coincidence that 15 is divisible by 5. So since both of these are radicals, you can do that division. All right, look, say if I have radical 10 divided by radical 2. Guess what? That's radical 5. Let's say if I had radical 12 divided by radical 3. Guess what? That's radical 4, which would be 2. So if they're both radicals, you can go ahead and do the division. All right, let me just clean that up for a quick second. All right, so radical 15 divided by radical 5 is radical 3. So I can go ahead and divide here, and this is going to become radical 3. All right, so that will give me 3 radical 3 over 8. And that will be the final answer for number 5. Okay, how about number 7? Okay, there's nothing to simplify. That's the good news. The bad news is I can't simply divide radical 3 into radical 2. So I will have to go ahead and do radical 3, multiply by radical 3 in the numerator and the denominator. So in the numerator, that's going to give me 5 radical 6. Okay, and so that is showing you that if both numbers are in radicals, you can go ahead and multiply those and get radical 6. Now I'm going to have this 4 times 3. Radical 3 times radical 3 is regular 3. So that's going to give me 5 radical 6 over 12. And that will actually be the final answer for number 7. So that's pretty straightforward. Notice that I cannot reduce between the 6 and the 12, right? Both of those are divisible by 6. But radical 6 is inside of a square root. The 12 is not. So they will not interact. You can't reduce those. All right? If they were both in radicals, then I could. All right, let's do one more. So again, I see nothing that I can actually simplify, but I can do, so I will just multiply by radical 5. So I'm going to multiply by radical 5 in the numerator and the denominator. Okay, when I do that, in the numerator, I'm going to have the 5. Radical 2 times radical 5 is radical 10. And then radical 5 times radical 5 is just a regular old 5. However, these 5s cancel each other out. So that is going to leave you with radical 10. Okay, by the way, radical 6 and radical 10 cannot be simplified any further because, take radical 10 for example. If I did the factor tree on this, this is just 2 times 5. So radical 10 is the same thing as radical 2 times 5. But there are no doubles. Okay, remember when we've done this in the past, if I had double 2, that became a regular 2. But there are no doubles here, so there's nothing to come outside of the radical. And same thing with radical 6. Radical 6 is the same thing as radical 2 times 3. But that's as far as it goes, and there are no doubles to come out. So you just leave it radical 6. All right, anyway, that is it for number 9. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.